There are several different kinds of collection classes. One of them is the list. This example is one of the list types, the linked list. It's one of the forms of an ordered list. This is where the linked list itself is constructed. Now, this collection object is created to hold a list of string objects. Notice that the type of object it holds becomes a part of the name of the class, which means it becomes a part of the name of the constructor of the class also, so it has to be specified in both locations. 4 strings are added to the list. Now, this is an ordered list, and the add method just puts each one at the end of the list. The call to add first inserts a string at the beginning of the list. Each of the list types work a bit differently, but you can add things to the beginning and end of them, and you can remove things from the beginning and end and anywhere in the middle. There are several method calls to manipulate the list contents by adding new things to the front and back, replacing things in the middle, and removing any item from any position in the list. You can work with items in the middle of the list, but this collection is primarily designed to provide access to the beginning and ending. A list iterator object is returned from the list iterator method. Notice that the object returned is specific to the type of the object that this list contains. Anyway, using the hasNext method returning a Boolean for testing and the next method for reading the references, all the string objects are returned. And they're returned in the right order. Here you can see that the strings were all added and returned in order, and that the add first method has put its string at the head of the list. You can also set up queues that operate like a FIFO, first in, first out. This example uses an array blocking queue, which is a FIFO queue of a fixed size that uses an internal array to hold the objects. This is the constructor of the queue itself. There are other types of queues, but this particular queue is constructed with a fixed maximum size of 30 entries. It's called a blocking queue because if you call the put method to add a new member to the queue, and the internal queue happens to be full, the method sleeps until there is space for it. You can see how this queue could be used to pass objects from one thread to another, with the sending thread possibly waiting for the receiving thread to drain down the internals. Anyway, just like previously, this queue is constructed to accept only string objects. The put method is called a few times to insert some string objects into the queue. Now, the put method requires a try block because of the sleep that could be imposed. If the sleep were to be interrupted, that would cause an exception to be thrown. There is no iterator necessary for the queue because the poll method is the output of the internal first-in, first-out list. The put method inserts the strings, and the poll method takes them out the other end. The return value from the call to the size method is the number of strings still in the queue. Here you can see that the strings came out in the same order they went in. This is just a demo, but a queue like this is usually set up for asynchronous operations where one procedure is inserting things in the queue for another procedure to take them out when it needs them. It could be, for example, data records coming in over a link and being placed into the queue, while the program that processes the data is taking them out of the queue as it has time to get to them. Let me show you one more type of collection. A map has entries made up of a key value and the data associated with the key. You can specify that the key and the data be of different data types. Look at this. This is the line that constructs the new tree map. Now, this one has 2 data types specified to become part of its name. The 2 are inside the same set of less than and greater than brackets and separated by a comma. I have selected the key objects to be integer wrapper objects and the data to be strings. In this case, the put method requires two arguments. The first is the key, the second is the data. In this example, the second one, the data, is a string, so it's of the right data type. The first one is a literal integer, but the required type is an integer wrapper, so it is automatically boxed in this method call. You can't use fundamental data types as the key. You could only use objects. So this is one place the automatic boxing and unboxing comes in pretty handy. 4 entries are made into the map. Now, this is a tree map, so the entries are going to be sorted and come back in key order. There are other maps that do it other ways, but the tree map does a nifty job of keeping things sorted in key order. After they have been added to the collection, you can read them back by their key values, which is done with the get method. Now, a fundamental int variable is used in the argument to the get method, but the get method requires an integer wrapper, so this is another case of automatic boxing. Each line displays the value of the key and the string that's associated with it. The final output looks like this. This time, the strings didn't come back in the order they were entered. They came back in ascending order of the keys. Now, there are other containers, and you should spend a little time browsing the collections and the documentation just so you know what's there. That way, in the middle of your programming, when you discover that you suddenly need to create a collection, you'll have a good idea which collection it is that you really need.